The speed of light isn't constant. What if I told you the one thing every physicist agrees is impossible has been measured in laboratories around the world? The speed of light, that sacred constant carved into the foundation of modern physics, might not be constant at all. This sounds insane. We've built our entire understanding of the universe on one assumption. Light travels at exactly 299,792,458 meters per second. Always, everywhere, no exceptions. It's the cosmic speed limit, Einstein's unbreakable law. But here's the disturbing evidence. Portuguese physicist João Magalhães couldn't sleep at night because of a cosmic puzzle. The Big Bang's afterglow looks identical across the entire universe regions, separated by billions of light years that should never have communicated. It's like walking into a concert hall where thousands of people clap in perfect sync despite being unable to see each other. Magalhães' solution? What if light used to be faster? What if the speed of light has been changing throughout cosmic history, slowing down as the universe aged? Then, in 2013, researchers at the University of Glasgow did the impossible. They split photons and raced them along different paths. Same light, same starting point. The photons through empty space arrived first. The ones through a design mask arrived later. Different speeds. Measurable, reproducible, real. Dr. John Webb's team spent 20 years analysing ancient starlight 10 billion years old. That light carries fingerprints revealing the fundamental constants when it began its journey. The results are controversial and absolutely fascinating. The speed of light appears to follow patterns, clustering around preferred values, as if reality has favourite settings. If light speed truly varies, every GPS satellite needs recalibration. Stellar evolution models collapse. The universe's age becomes negotiable. But here's the uncomfortable question that should terrify you. If the most fundamental constant in physics can change, what else might be variable? Are we living in a cosmos where the laws themselves are just suggestions the universe sometimes chooses to ignore? Quantum particles. Remember the future. In 2007, a quantum particle made a decision about its past 3 nanoseconds before the decision was made. This isn't science fiction. This is what happens when cause and effect, those reliable partners that govern reality, sometimes work backwards. This sounds insane. We assume the past determines the future, not the other way around. That's how time works, right? Events happen in order. Cause, then effect. Always. But here's the disturbing evidence. Scientists fire photons through double slits, creating wave patterns. Then they tag each photon with which slit information, like giving particles name tags. Instantly, the wave pattern vanishes. The photons somehow know they're being tracked. The quantum eraser experiment cranks this up to 11. After photons pass through slits, but before hitting the screen, scientists split each one into entangled twins. The signal photon hits first. Its entangled partner travels a longer path. Here's where reality breaks. The first photon's behavior depends on what happens to its partner nanoseconds later. If the delayed measurement reveals path information, the early photon retroactively becomes a particle. If the measurement erases that information, it retroactively becomes a wave. Dr. Yoon Ho Kim proved this at Johns Hopkins in 2000. Photons were making decisions about their wave or particle nature based on measurements that hadn't happened yet. The future was determining the past. Physicist John Wheeler took it cosmic. When light from distant quasars bends around galaxies, it takes 2 paths to Earth, like passing through 2 slits. Our choice today about how to measure that ancient light force's photons that travelled for billions of years to retroactively decide whether they were waves or particles when they first left their source. Your decision in this moment reaches back 10 billion years to determine reality when the cosmos was young. But here's the uncomfortable question. If particles rewrite their history based on future observations, is the universe's past constantly under revision? Are we editing cosmic history every time we look at the stars? The universe has a pixel limit. Deep in the fabric of space-time, reality has a resolution, and we've found it. Like zooming into a digital photo until you see individual pixels, the universe breaks down into discrete chunks at its smallest scale. And this sounds insane. We imagine space as smooth and continuous, infinitely divisible like a perfect geometric line. You should be able to measure smaller and smaller distances forever. But here's the disturbing evidence. The Planck length 1.6 times 10 to the negative 35th meters represents the smallest measurement with any meaning. It's so tiny that if you scaled an atom to the size of the observable universe, the Planck length would be about the size of a tree. Below this scale, the concepts of distance and measurement break down completely. It's not that we can't measure things smaller. Smaller than this has no meaning. Space becomes granular, pixelated, digital. Edward Fredkin, Stephen Wolfram, and John Wheeler proposed the universe might literally be a computer. Each Planck-scale cell follows simple rules. Combined across trillions of cells, they create complex reality. Wheeler called it from bit, every particle, every force emerging from information processing at reality's smallest scale. Loop quantum gravity takes this seriously. Space isn't made of points, but tiny loops like chainmail armor of quantum geometry. Each loop exactly one Planck length. The holographic principle delivers the knockout punch. All information in any volume of space gets encoded on its boundary like a hologram. But there's a limit, 1 bit per Planck area. The universe has maximum information density, a pixel limit beyond which no detail can exist. LIGO gravitational wave detectors might have found proof. Some researchers claim they've detected tiny fluctuations as waves pass through space's granular structure. The signals hide at the edge of detectability, but they match what pixelated spacetime would produce. Computer simulations of granular spacetime naturally generate quantum mechanics. Uncertainty principle, wave-particle duality, entanglement all emerge from discrete information processing units. But here's the uncomfortable question that should shake your reality. If the universe has a resolution limit, are we living inside mathematics itself? Are we experiencing reality as the solution to an enormous equation calculated 1 Planck unit at a time? Missing antimatter and the cosmic glitch. The Big Bang should have created equal amounts of matter and antimatter. So why does anything exist at all? The answer suggests our universe is running on broken code. This sounds insane. Physics demands symmetry. For every particle, there should be an antiparticle. When they meet, they annihilate in pure energy. Einstein's E equals mc squared at perfect efficiency. But here's the disturbing evidence. The Big Bang should have created perfect balance. 1 proton for every antiproton, 1 electron for every positron. Everything should have annihilated within seconds, leaving only photons and empty space. No atoms, no stars, no planets, no us. Just endless radiation cooling into darkness. Yet here we are. Every star, every planet, every atom in your body is matter, not antimatter. For every billion matter-antimatter pairs that destroyed each other, 1 extra matter particle survived. That tiny imbalance, 1 part in a billion, is why anything exists. In 1964, physicists found the glitch. Kaon's particles decay differently depending on whether they're matter or antimatter. The universe has a built-in preference for matter. It's like finding a cosmic typo in reality's source code. But the glitch is too small. Laboratory measurements show nowhere near enough asymmetry to explain our matter-dominated universe. We need 10,000 times more bias than we observe. It's as if we found evidence of a hack but can only see a fraction of the actual code. Recent experiments at the Large Hadron Collider found new violations in B mesons and D mesons. Each discovery adds pieces to the puzzle, but the complete picture remains hidden. The most unsettling possibility, this isn't accidental. The anthropic principle suggests we observe a matter universe because we couldn't exist in any other kind. In a multiverse with different violation levels, we inevitably find ourselves where the glitch worked perfectly. But here's the uncomfortable question. If physics can be glitched to create matter from nothing, what other bugs are running in the background of reality? What else might be broken in ways that accidentally work in our favour? The great attractor's invisible pull. Something invisible with the mass of 10,000 galaxies is pulling our entire cosmic neighborhood through space at 2 million kilometers per hour. We can't see it. We don't know what it is. It's been dragging us for billions of years. This sounds insane. We should see something that massive. An object containing tens of thousands of galaxies should blaze across our telescopes, impossible to miss. But here's the disturbing evidence. In the 1970s, astronomers mapped galaxy motion expecting uniform expansion. Instead, they found thousands of galaxies flowing like a river towards something hidden behind our own Milky Way. Our galaxy races toward this invisible anchor at impossible speeds. The zone of avoidance blocks our view. Like trying to see mountains while standing in a thick forest, the dust and stars of our galaxy create an impenetrable barrier hiding whatever's pulling us through space. Infrared telescopes peer through the dust. Radio telescopes detect hydrogen emissions. What astronomers found was stranger than expected, a complex structure of clusters and voids arranged in patterns that shouldn't exist. Massive concentrations where simulations say they can't be. Empty regions where galaxies should have formed but didn't. Even accounting for dark matter, the numbers don't add up. The Great Attractor appears more massive than the sum of everything visible and dark that should be there, but it gets deeper. The Great Attractor itself gets pulled towards something larger, the Shapley supercluster. Beyond that, dark flow suggests coordinated motion across billions of light years, as if the entire observable universe streams towards something beyond our cosmic horizon. Some propose cosmic strings, one-dimensional space-time defects create these gravitational effects. Others suggest modifications to gravity itself. The most troubling possibility, we're seeing structure beyond the observable universe. But here's the uncomfortable question. Are we passengers on a cosmic ship being pulled by invisible forces toward a destination we cannot see? And if structures this massive can hide from us, what else might be lurking in the cosmic shadows? Quantum tunneling through impossible barriers. Every second, particles in your body teleport through walls that should be impenetrable. Right now, electrons vanish from one side of barriers and materialize on the other without ever existing in between. This sounds insane. Classical physics says if a ball hits a hill without enough energy, it rolls back. There's no way for it to appear on the other side without climbing over. But here's the disturbing evidence. At quantum scales, particles behave like probability waves. When electrons hit energy barriers they can't overcome, their wave functions extend through the barrier, creating non-zero probability they'll materialize on the other side. Reality constantly rolls dice, and sometimes the impossible wins. George Gamow predicted this in 1928 to explain radioactive decay. Alpha particles don't have enough energy to escape atomic nuclei, yet they tunnel out anyway like ghosts through walls. Without tunneling, the sun wouldn't shine. Hydrogen nuclei in stellar cores repel each other with tremendous force. They don't have nearly enough energy at 15 million degrees to overcome electrical barriers. Classical physics says fusion should be impossible, yet it happens billions of times per second because nuclei tunnel through barriers they shouldn't cross. Every photon reaching Earth from the sun exists because particles violated the rules. Every plant photosynthesizing, every breath of oxygen, every sunrise depends on quantum tunneling on stellar scales. Your computer relies on tunneling too. Modern processors use billions of transistors where electrons routinely tunnel through insulating barriers. Engineers design around quantum leakage and exploit it. Flash memory uses tunneling to trap electrons in quantum wells, storing information at atomic levels. But tunneling's relationship with time breaks causality. Recent experiments suggest tunneling happens instantaneously. Particles don't gradually seep through barriers. They vanish and instantly reappear. Some results indicate tunneling faster than light, with particles seemingly exiting before fully entering. But here's the uncomfortable question. If fundamental particles routinely violate barriers that should confine them, creating the miracle of organized matter and life itself, what other impossibilities might be hiding in plain sight? The observer effect beyond the laboratory. What if looking at the night sky literally changes the stars you're observing? This isn't poetic metaphor, this is quantum mechanics extended to cosmic scales, forcing us to reconsider humanity's role in shaping the universe itself. This sounds insane. We assume stars exist independently, burning billions of miles away regardless of whether we observe them. Surely astronomical objects are too big for quantum weirdness. But here's the disturbing evidence. Laboratory quantum mechanics proves measurement changes reality. Observe an electron's position, you alter its momentum. Check which slit it passes through, you destroy wave interference. Measurement fundamentally alters quantum systems. If quantum mechanics is universal, the observer effect shouldn't stop at laboratory doors. Every telescope pointed at distant objects might collapse astronomical wave functions, determining cosmic realities that existed in superposition for billions of years. John Wheeler's participatory universe hypothesis suggests observers don't just receive information about reality, they actively create it through observation. The universe exists in vast quantum superposition until conscious observers collapse possibilities into actual history. When we observe light from stars 100 light-years away, we might not just be seeing how they were, we might be determining how they were. Stellar pasts could exist in superposition until our telescopes force them to choose specific histories. Cosmic double-slit experiments with distant quasar light show the same interference patterns as laboratory tests. Light from objects billions of light-years away still behaves quantum mechanically, still responds to how we choose to observe it. Delayed choice experiments take this further. When we decide today how to measure ancient galaxy light, we retroactively determine quantum states photons had millions of years ago. Present choices reach through time to establish past reality of objects we're observing now. Some interpretations suggest the entire early universe existed in superposition until conscious observers emerged to collapse cosmic wave functions. Life and consciousness weren't just outcomes of evolution, they were necessary for evolution to have definite outcomes. But here's the uncomfortable question. If every astronomical observation collapses cosmic possibilities into specific reality, are we discovering the universe's history or creating it? Every time you look at stars, are you seeing the cosmos or helping to create it? Dark energy's accelerating mystery. 70% of the universe is made of something that shouldn't exist, and it's tearing space-time apart at accelerating rates. We call it dark energy, but that's just a label for cosmic ignorance. This sounds insane. Energy and matter should become dilute as space expands like air spreading from a punctured balloon. Gravity should slow cosmic expansion, eventually pulling everything back together. But here's the disturbing evidence. In 1998, astronomers studying distant supernovae expected to measure cosmic deceleration. Instead, they discovered acceleration. The universe expands faster each moment. Something overwhelms gravity on the largest scales. Dark energy violates everything we thought we knew. Normal matter dilutes as the universe grows. Dark energy maintains constant density. As space doubles, dark energy doubles too, created from nothing to fill expanding void. The numbers are disturbing. Dark energy, 70% of the universe. Dark matter, 25%. Everything we can see, touch, measure, the entire periodic table, every star, galaxy, planet comprises less than 5%. We're a tiny minority in a cosmos dominated by phenomena we can't detect or explain. Quantum field theory predicts vacuum energy from virtual particles constantly appearing and disappearing. But calculations give numbers 10 to the power of 120 times larger than observed dark energy. That's 10 followed by 120 zeros, the worst prediction in science history. The timing seems suspicious. For most cosmic history, matter dominated. But 5 billion years ago, right when our solar system formed, dark energy took over. This cosmic coincidence, the coincidence problem, seems too convenient. Some propose quintessence, evolving dark energy that changes properties as the universe ages. Others suggest dark energy doesn't exist, we're misinterpreting observations. Maybe gravity behaves differently on cosmic scales. The most disturbing possibility, dark energy is exactly what it appears. a fundamental space property that will accelerate expansion forever. The universe heads toward cold, dark emptiness where galaxies drift beyond light's reach, stars burn out, everything dissolves into isolated particles across unimaginable distances. But here's the uncomfortable question. If 70% of reality is completely alien to us, if the universe runs on energy sources we can't understand using physics beyond our theories, what does that say about how little we truly know about existence itself? Entanglement across impossible distances. Two particles separated by the observable universe's width just shared information faster than light. This is quantum entanglement at cosmic scales, suggesting the universe operates on principles that make our understanding of space, time, and causality seem quaint. This sounds insane. Einstein called it spooky action at a distance. Nothing should travel faster than light. Information can't jump instantly across galactic distances. But here's the disturbing evidence. Create two particles from one source. They become quantum twins, sharing mysterious connections regardless of separation. Measure one spin. Its partner instantly knows to spin oppositely, even on the galaxy's far side. In 2017, physicists used light from quasars 7 billion light-years away to control entanglement experiments on Earth. Ancient light that began traveling when the universe was half its current age randomly chose measurement settings for entangled particles in terrestrial labs. This cosmic bell test proved entanglement isn't limited by distance or time. Particles entangled on Earth maintained spooky connections even when measurement settings were determined by events occurring billions of years ago across the observable universe. Information about Earth particles was somehow connected to distant quasar properties from before our solar system existed. The universe appears threaded with instantaneous connections ignoring relativity's speed limits. During the Big Bang's first moments, when the observable universe was smaller than an atom, every particle contacted every other particle. They were all entangled in a vast cosmic network of instantaneous connections. As expansion separated particles by billions of light-years, those entanglements might persist. The universe today could be permeated by quantum entanglement webs, with particles everywhere connected through spooky action. Recent quantum teleportation experiments achieved Earth-to-satellite transmission, demonstrating entanglement persists through space vacuum and atmospheric interference. Chinese scientists extended this over 1,400 kilometers, founding global quantum internet infrastructure. If entanglement scales to cosmic distances without degradation, the universe might be fundamentally non-local. Information could flow instantly between any space points, creating hidden reality layers connecting everything. But here's the uncomfortable question. If every atom in your body is quantum entangled with particles throughout the universe, if consciousness emerges from universal quantum networks, are we separate beings or nodes in a vast cosmic information system that transcends our understanding of individual existence? The Fermi paradox and the silent universe. In a universe with billions of habitable worlds, the most disturbing sound is nothing. This cosmic silence represents either the greatest mystery in science or the most terrifying answer about our place in existence. This sounds insane. Our galaxy contains 400 billion stars. Recent space telescope discoveries suggest nearly every star hosts planets. Conservative estimates indicate billions fall within habitable zones. Even if life is incredibly rare, 1 in a million, the Milky Way should host thousands of technological civilizations. But here's the disturbing evidence. We scan skies with sensitive instruments, listen across every frequency for intelligence signals, search for heat signatures from advanced engineering. We find nothing. The universe appears empty of technological life, a cosmic wasteland where only one species developed radio telescopes and space travel. Enrico Fermi asked, "Where is everybody?" Simple question, profound implications. Either we're alone in a universe that should teem with life, or something's fundamentally wrong with our assumptions about cosmic evolution, technological development, or intelligent species survival. The paradox deepens considering the universe's age. Our sun is young compared to many galactic stars. Civilizations could have billions of years head start. Even at sublight speeds, determined species could colonize the entire galaxy within millions of years, a cosmic blink. Where are ancient ruins, abandoned structures, waste heat from massive engineering? Why hasn't anyone sent probes, transmitted signals, or left obvious markers for younger civilizations? The Great Filter hypothesis chills. Some evolutionary bottlenecks so difficult, almost no species survives. The filter could be behind us: complex cells, multicellular life, intelligence, technology. We might be alone because we're the only ones navigating the deadly maze, destroying species before they reach the stars. Alternatively, the Great Filter lies ahead. Maybe every technological civilization faces insurmountable challenges: self-destruction, environmental collapse, resource depletion, or contact with something that destroys them before establishing lasting galactic presence. Advanced civilizations might deliberately hide, following cosmic protocols preventing contact with primitive species. Truly advanced beings might exist in exotic forms we wouldn't recognize. Digital consciousnesses, post-biological entities, beings operating on vast timescales where our entire civilization appears as brief flickers. But there's another possibility connecting to all the universe's glitches. What if cosmic silence isn't evidence of uniqueness, but evidence we're living in simulation? Simulated universes might need only minimum detail for our local reality pocket, leaving the galaxy empty to conserve computational resources. Alien absence could be the ultimate universe glitch, a debugging feature revealing artificial existence. Like video game distant objects appearing detailed but lacking substance when examined, the universe might be full of seemingly habitable planets containing no life because no one observes them. But here's the uncomfortable question that should haunt your dreams. As we continue searching skies and finding only echoes of our signals bouncing from empty space, are we the universe's only witnesses to its existence, or simply the only ones programmed to believe we're real? So there you have it, 10 glitches that shatter everything we thought we knew about reality. We've journeyed from light that rewrites physics to particles that edit their own past, from cosmic silence that defies explanation to invisible forces tearing space-time itself apart. But here's the final, most disturbing question. Are we discovering the universe's magnificent weirdness, or are we finding cracks in the code of our simulated existence? Maybe the answer is that both possibilities are equally terrifying. If your worldview just got completely obliterated, smash that subscribe button, because I've got more reality-breaking discoveries that'll make today's glitches look tame. Share this video with someone brave enough to question everything, and let me know in the comments. Which glitch broke your brain the most? The universe might be fundamentally broken, but our hunger to understand it remains unglitched. Keep questioning, keep wondering, and remember, the most mind-bending truth might be the one we haven't stumbled upon yet.